Math science video. Physics, of course. Um, yeah, so where to begin? So I'm going to talk some more about this interaction thing, but just more general stuff again, just trying to get to the, gee, this is so simple. You know, and it explains it all. So anyway, in the comments, so this Mr. Grimm guy, or Grimve, anyway, I have an interest and don't care for credit or copyright. Let's talk. Okay, well, you're just not getting it. Make a video. I can't talk if you're not talking. I don't see any real value in having some back and forth conversation. I mean, either you have something to say or you don't have something to say. I mean, I don't, I, yeah. And so you can make a video that's unlisted. You know, if you don't want it on your channel, you just make an unlisted video and post the link in one of my videos, and then it can just be a sort of a conversation about some element you need more information about, or that you disagree with, or what about this experiment that demonstrates, you know, you can do that kind of thing. So do that kind of thing. But I don't know what, you know, I can only solicit participation in. That's all I can do. I mean, I can ask, and you can either do it or not do it. But I don't, you know. It seems to me videos is a good way to communicate. So use it. It's a method of communication, or even an audio file. I don't really care that much, but I mean, make your point known somehow. Yeah. Yeah. It's enough on that. Yeah, I really, you know, I got to get some sort of counter argument in some form, sometime, sooner or later. Anyway, so this logical empirist guy is such a fucking cunt. But this Truth Quest guy is also, you know, an idiot. But anyway, he's calling the idiot's calling an idiot, and all that kind of stuff, which is kind of funny. So anyway, this just, you know, nothing can exist without quantum fluid. I mean, you know, okay, fine. I mean, I just don't understand quantum fluid. So you mean a fluid made out of quantum bits? Oh, okay. I guess that's sort of what I'm saying, isn't it? Yes. Quantum fluid are photons. Well, again, let's understand what a photon is. A photon isn't a photon. A photon is two quantons. But whatever. It's sort of important. So, I mean, I would say the fluid isn't photons. Because photons aren't photons unless they have the right frequency to be categorized as a photon. Photons do not have a real movement, says you, but only a frequency. Obviously a frequency between what? Not moving and not moving? They obviously have to be, even a wave has to move. Has to be a moving wave. Can't just be standing there. I guess you could say that a photon is a particle made up of two quanta, but it would be matter and antimatter, says you. There's no such thing as antimatter anyway. It's just a silly notion. But whatever. Believe what you want to believe. What can I say? It's not that complicated. You know, you could say that a photon is a particle made up of two quanta. Well, there you go. It's not really a particle, though. Two particles. The quanta are the particles. The relationship between them is the photon. You don't call the photon a particle. I know that's the whole argument, is that photons are particles, but it's not like the photon itself is a particle. The thing the photon is made of is particles, just like the neutron is made of particles, and just as the electron is made of particles. Alright, well, anyway. So then, so this guy, I'll read his shit here. Listen here, homo nanildiddly. I don't know what that means. You ain't found a new grand unifying theory. You think you have, but you did not. Ooh, says this guy. People 100 years' time won't be studying these videos. People 100 years from now aren't going to be studying anything, but they're going to be radioactive and dead. In looking for some small detail or anecdote by the great master, you don't need to use my real name, asshole. It's just rude. The greatest physicist of all time. Yeah, but whatever. The point isn't whether I'm a great physicist. The point is whether the past physicists were great physicists. And I guess sort of the accusation is they were really shitty scientists because they just kept talking out of their ass. Okay, they did some guesswork. They liked the guess, almost like a God story. They wrote a God story, and then they said, I like this God story. Let's make it real. And they really didn't have reason to make it real. And the quantum mechanics has always been based on just a fluffy idea floating around. They say, oh yeah, that fluffy idea, look, okay, yeah, the photon goes through both slits and it makes two waves and it does all this, blah, blah, blah. And even in the single slit experiment, it makes two waves. How does it do that? Just says I'll do that. Even though I could make 1,000,000 waves, I'll just make 2, so the math works. That's really bad science, in my opinion. No way I'm pretty sure about that. Well, you're pretty sure about that based on what? Oh, I would say nothing but your own prejudice and bigotry. I myself cannot disprove you, because what you say is not disprovable by definition. Well, no, what I say is disprovable. It's just as disprovable as any other theory. It's certainly just as disprovable as Einstein's nothing space telling the something what to do. I mean, it's certainly as disprovable as that. Idiot. I mean, fuck. Though it's just certainly as disprovable as the photon goes through both slits and turns into a wave and then decides to become a particle again. Yeah, it's certainly as disprovable as that. Therefore, it ain't science. It's not even folk physics. Well, again, I would argue that entire quantum mechanical diagram, this whole standard model isn't science, jackass, isn't physics, isn't any of that shit. Physics by former species Homo who didn't have first clue about what we are, blah, blah, blah. I won't even bother looking at the last little bit. And then the Truth Quest guy argues one, which is funny. You don't know shit. Go back to your little box of smart asses, and think that they know everything about the universe. Talk about the subject for 2 fucking hours and at the end say that they don't really understand the subject they just spent 2 fucking hours talking about. So he's just making a shot at the standard physicists and their bullshit, which is bullshit. I'll agree, but I think his comment was different before. It said something about Einstein was wrong and something else, or it must have been edited or something. I don't know. It seems to me. I just recall there's some sort of crap about Einstein. Yeah, Gary admits it's a journey and relatively objective to listen to other people. Huh? I don't know what that means. You're not in your world. If Einstein didn't approve it, it must be shit. When in reality, you and Einstein are full of shit. There we go. Tesla. Oh, that's it. Tesla again. I mean, it's like truther talking to truther. I mean, this whole Tesla is God shit is just so fucking idiotic. But it was insane. All insane people are brilliant. No. Some insane people are insane. Shit. Anyway. So, yeah, these are not very useful comments, to say the least. Yeah. To say the least. Alright, so is there anything else on here that I have to get to? I don't think so. So I can start doing my thing. Okay. So, yeah, so the first big insight is the whole nuclear gravity. Okay, gravity is a subatomic force, not a material force, and that's what it affects, is the tiniest bits of you. That's when this happens, you know, velocity on part of your body. It's because that part of your body isn't really part of your body. I mean, it's all independent little bits, and they just happen to be in a collective that is going to obey certain rules based on the transference of energy, arrows, from one to another. So I guess that's the simplest way to look at this in the first instance, is just to say, okay, if you took 2 things here, and you said this one had a velocity of 3 miles an hour in that direction, right? All that really means is that this, like you could take 2 identical substances, that this one has a certain percentage, by a certain percentage rule, this one has more arrows inside of it. Okay, it's collected them, and that's why it's moving in this direction. It's because it has collected more arrows going in this direction. So with all the arrows going in all kinds of directions inside of something, this one has a percentage, I don't know what that would be, 0.0001% more would equal 3 miles an hour. But it's always a proportional amount, proportional to mass. And yeah, so that's all there is. There's just transferring these arrows. This when my hand moves, when my hand's doing this, what it's doing is it's being forced to have a bunch of arrows are being shoved into it going that way, and that my hand goes that way, and then those arrows are transferred for arrows going this way, energy going that way, stored, directed momentums. I don't know. I'm just saying it's a collection. You're collecting. You can only collect an arrow. So this is the thing to understand. These arrows cannot be created or destroyed. Okay, so the quanta cannot be created or destroyed. They always have they're doing their thing, and that's it. They will not change that thing, essentially, ever. And all you can do is collect them. Oh, okay, that's the wrong way to put it. They can change this thing if you slow them down. Alright, so if you slow them down, then you can keep them somewhere. So when they're slowed down enough, you can keep them somewhere. So they have to be slowed down by interaction. So that's where this interaction, time of interaction thing becomes so fundamental. Alright, but I don't want to lose the real value point here, which is the velocity is elemental. So when you acquire velocity, you're acquiring an elemental thing. You're actually acquiring a real bit of directional information in a direction. A thing in a direction is what you've acquired. And you have more of that thing. And again, the way you collect these things is by creating these highly interactive orbitals, systems. And unlike the solar system, which seems kind of boring, these systems are very active in that every turn of the orbit, so you have to understand that this thing's going, every single turn of an orbit inside of a subatomic particle, every single one of these, it has to be hit. Every single one is an interaction. And if you understand that it's the interactions that create the idea of time, the fact that the interactions take time, and that the more interactions you have, the longer it's going to take to get somewhere. And by just the simplest understanding, you can just see if this was a 10-sided turning object, you know, if it had facets that were, you know, if you thought of it just facets, the arrows, right there you got at minimum you have those 10 interactions. So you have 10 times more interactions than you might have if you're going in a straight line, or 8 times more. A much higher density of interactions have to take place for you to be able to maintain that orbit. It's the only argument being made. Just by its structure. You can't have the structure without the interaction. So it's a guarantee, this minimum amount of interactions. And that's what's creating time. So, I don't know if I want to get into the whole velocity thing again, but yeah, I just want to say that it's this clear. It really is. The bottom line is it's this obvious, in the sense that it's just a collecting of stored directional information. So when one thing stops moving, another thing starts moving, what's been transferred, okay, is a directional imbalance that existed in one thing, and it was moved to another. So one thing had orbits that were, heavier on one side than they were on the other side, and it just it transferred that imbalance. This one became balanced, and the other one became imbalanced. And that's all that's really happening. It's a transfer of a real thing. There's no momentum is a real thing. velocity is a real thing. It's a real change in the actual matter, and that's why it maintains the velocity. Now, the reason why that slows time down, why there's time dilation, is that as you increase the velocity, you increase the number of interactions. You don't change the idea of this simple transfer argument I've made many times that I have to, I'll keep illustrating. That two things come in, in an interaction, and you can see it as being this goes straight through that and this goes straight through that, or you can see it as this being turned and this being turned. So you can perceive it either way, but the bottom line would be is that something moving in a direction is going to keep moving in that direction, and you're not going to be able to stop that. So any pattern or anything else would always be there. But the point is that only if it has a consistent number of interactions. If it has a whole bunch of interactions, then it's not going to be here. It's going to be way back here. And that's the difference. You can slow things down. And when something has velocity, it's creating a lot more interactions. The same end result will take place. It will go in this direction, but it will go in that direction slower because it has an increased number of interactions. They're consequentially the same in the sense of the direction, but they are substantially changed in terms of the speed. And so even though, so it sounds contradictory to say it has a velocity, so it's actually moving, where something else is stationary. But the truth is, by moving, it's creating more interactions to do the moving. And those increase in interactions slows down how fast the thing's actually moving. The bit's actually with this directional information in this direction. The bits going in the direction the thing is going are actually ending up moving slower. Everything else is moving really fast. If it's going in some other direction, it's having fewer interactions, it's moving really fast. But in the direction of the motion, there's more interactions, and it's actually moving slower. So ironically, in the direction that you have more arrows going in, is the direction you're going the slowest in on a nuclear level. But the fact is you have extra arrows in that direction, so at net you'll go faster in that direction as a mass, because those extra arrows are changing all the other arrows in that direction. They're pushing all of them in a direction. Pushing is the wrong way to say it. They're interacting with the other stuff and doing this illusionary thing where half of it goes this way and half of it goes that way, but the part that's significant is the this way part. Oh, yeah, that doesn't say it deep enough. Alright, I'll have to come up with a better way to draw that. But the idea is that this idea that time is created by interaction is just really critical. It's the time. Time is created by interactions, and obviously stuff in orbits has more interactions. It has to keep getting pushed off course, so to speak. It has to keep having interactions that create the exchange of direction, and that's literally what's happening. It is an exchange of direction. Even though something new is going off in your old direction, it is something new going off in the old direction. So a photon you're seeing just isn't the same photon. The quantons making up the photons you're seeing are not the same photons that, say, left the camera or left my eye or whatever. They're always getting exchanged. We're constantly, every bit of us is exchanged in these interactions. All right. I was going to say a word like field density, but that doesn't even quite say it. But it's the density of potential for interaction that is the essence of mass or matter. Okay, so anyway, so those are the three fundamental aspects here. Is that the gravity is nuclear, subatomic, and it's made of these gravitons or quantons, these little bits moving the speed of light, which is always relative to the density of the field it's moving through. So if it's moving through matter that has a lot of interaction potential, it'll move slower because it's moving through something where it has to have a lot of interaction, so it takes a while for it to get through it. And that's a fundamental. Another element of that is this understanding that when, like say when gravity's moving through you, so the graviton is coming from space where it had a certain speed, which was the speed of light, and then when it hits you, it's having all these interactions. So its speed greatly reduces as it goes through you. And as that's happening, this time change, right? I mean, this is a much longer time. This is time times whatever, 20, and this is t equals 1. You know, this kind of stuff. So you went the same distance as you went here in 10 times more time. And what's happened in that 10 times more time is that you have extruded, the arrows going in other directions. You've gotten rid of the arrows that are not in this direction, particularly the arrows going in the opposite direction are the ones you've gotten rid of. So you have equally an opposite released force in the opposite direction of your velocity that you're acquiring through acceleration. But the acceleration itself greatly compresses time through the increase of interactions. And this compression of time means that the gravity that would be here, okay, hitting something like the Earth below you, is caught in here, temporarily, through this time problem, and it's not getting here. So there's a lack of gravity here, a lack of quantons coming down to the Earth. And that lack of quantons is creating an imbalance in the Earth, which is forcing the Earth to move towards you. So this is the mechanism. The time delay shields something from what would be hitting it. Yeah, the time delay shields things in front of things from being hit with what they would have been hit with if the stuff wasn't stuck inside of them exchanging directional information. Yeah, I think that I can't say it. Probably could say it better, but that's not a bad way to say it. All right. All right, and then the other forces are accounted for through polarization that creates your magnetism and your electricity, and the strong and weak forces are basically magnetism. We call it charge, but it's magnetism. Yeah, and so it's magnetism and gravity, and they're still affected by. I mean, gravity is a sub-nuclear force. It still exists on the atomic level, and it's much stronger on the atomic level, obviously, because it's arrow against arrow. The bits are as small as the gravitons. The quantons inside the orbit of inside an electron, let's just say. Those gravitons, those quantons, are the same size as the things hitting them. So the force is substantial because the force is, on gravity as a force, is substantial because it's the same size as the size difference. So they can think of gravity as a weak force when they think of planets, and then make planets smaller. But it's not the same thing as making planets smaller, because you're making the force much bigger by comparison. The size of the quanton compared to the size of an Earth is hugely different than the size of a quanton versus a quanton. That's an equal relationship. So, I mean, if to understand it, you'd have to say, well, if you want to say gravity is a weak force, well, no, on the subnuclear level, make the thing hitting the Earth the same size as the Earth. Make the gravity quantons as big as the Earth, and then you'll understand how strong the force is on the quantum level. On the quantum level, gravity is a substantially strong force. So, that's sort of the deception here. is that when they say gravity is a weak force, it's not a weak force when you're as small as the force that's affecting you. And like I said, the other aspect of that is through polarization, you can increase or decrease sensitivity to those reactability. Let's just call it that. The likelihood of interaction can be changed based on polarization. So you can essentially make gravity invisible to something by changing polarization, just as you can do that with light. All right. So yeah, I think that's enough on that. It was close enough. All right. Yeah, so I think I've done enough with the velocity thing. So I want to talk a little bit about the photons and their absorption and this interaction thing, and how it. So you're probably not getting this idea of a pattern being almost impossible to break in a quantum field. You know, just because you have that X problem. The X problem basically guarantees that whatever's going that way is still going to go that way. You can never not go that way. But the trick is, you know, because of these orbiting things. So let's just create an orbit, you know, like a standard one. It doesn't, you know, it could be two things orbiting each other. It doesn't really matter. And let's say a string of photons is coming, and they have a specific wavelength and frequency, you know, coming this way, and they're going to interact with this thing, right? Well, it sort of depends on when this interaction happens. So theoretically, if this first thing hits this thing, you'll have this X thing. So we'll just make it a cross, right? I mean, this thing is still going to go its way, and this thing is going to still go its way. So something's still going to leave, okay, dotted line, and this thing is still going to be going this way. So it's going to crash into the next one, into the next one, into the next one. And you basically have the same. So let's just say this thing's going this way and these photons are going this way, just for clarity here. And so all of these will be time dilated by the interaction, because they'll all be forced to have the interaction. But what if this thing was over here when the first quanton of the photon was here? So this first one would go unmolested to here. And then this one moves into the thing, hits this second one. So now this second one has the interaction with this one. Get it? So this one now interacts with the second photon in the string, and the second quanton in the string that's making up a beam of light, or whatever you want to call it, a ray of light, or whatever. Electromagnetic radiation, it really doesn't matter, but let's just say for the sake of argument this is blue light coming in. And so what's going to happen is this thing will hit here, and then there'll be this time delay because of the interaction. So this one didn't have an interaction. It jumped from here to here. It went distance, whatever, let's say 1. This one has a time delay now because it's having an interaction. It will not go distance 1, it'll go distance 1/2, let's call it, just for the sake of fun. Because of this time delay, the fact that this one's still moving while this one's interacting. This one's using up time interacting. And so this one's gained distance away before this one can regain its connection to this one. So what's basically happened is this blue light has now been changed into maybe red light, or something short of red, because it would be 1 plus 1/2, you know, so it would be 1.5 distance. So it gained 1/2 in its distance between the photons. And because that, you know, once this interaction happens, it's just going to keep going through all of them. The rest of these following would also be time delayed, so they would retain that increase in distance between them, because they're going to keep getting time delayed by that same interaction. It's going to keep going right straight through all of them. But the key thing is that any number of them can get through this first hurdle without getting hit, and it can happen to something deeper in the photon. And that's what's changing light from, say, blue light to red light, is it's It's the time delay that's being created. And the inverse can happen where red light comes in, and if the orbit of the of the quanta is in the opposite direction, it can put something in between. So there's no interactions at all, but it just loses a quanton exactly in between the existing, and that would change red into blue. And that's how light's getting converted through these interactions, is that either extra quanton are being thrown into the wavelength and shortening it, or time is being imposed upon quanta within a ray of light, creating more distance, more separation, increasing the slowing down each quanta just the right amount to redshift its progression. Yeah. So I don't know if I need to. I mean, this is the first draft of me explaining it, and it's probably not the best I could do, but it's the best I could do with the time I have at the moment. And I really want to, start. Yeah, I got to start writing, and I got to start organizing this in a more deliberate way. But I just think these key ingredients to me are adding. I feel very strong about these things. The idea of the nuclear gravity, that's 100% now. I'm just 100% positive this is the way it works. Gravity is a nuclear force. It fits everything. It fits the inverse square law. It fits the idea that gravity is always the same no matter how much you reduce something's mass, no matter how you change its mass. It just doesn't matter. It's going to have exactly the same gravity for a certain location in space. It just makes sense that that the force is affecting the very atomic structure that is consistent among all things. And this idea of velocity being a real thing, it's not, and that's what's creating momentum and all this stuff, is that you're actually changing the matter of the thing. So when a thing has velocity, it's because its matter has changed. It has a higher percentage of a certain kind of quanton, and that's why it has velocity. And it will continue to have velocity until something changes the balance of quantons to just gets rid of that imbalance by putting more of the other kind in, the opposite ones in, the opposite direction. And this idea of time being completely connected to the fact that all this stuff moving is always moving through a medium, the medium of the force itself. So the whole entire field is essentially a medium where all the little bits are interacting with each other all the time, and that consumes time. And then the more densely packed the quanta are, the more in an area, the more interaction time, and the less progress in terms of distance that will be manifest. Something can't keep going its thin field speed is going to be much faster than its thick field. So as the water gets thicker, the speed slows down because the number of interactions increases. As it hits more stuff, it makes less progress. And so that is the creation of time. Time is just the manifestation of interaction, and in a fieldless environment there's no time because there's no interactions, and so there's no anything. Everything happens. It's an interesting paradoxical argument when you think about it for a second. Based on this model, just because there can't be any reality outside the field. because everything happened instantaneously. There's no creation of time. There's nothing to make time happen. And so nothing can happen. But I mean, that's sort of obvious also because everything that is happening is made of these quantons. There's nothing non-quantum, there's nothing non-material happening in the universe. So it's all dependent on the properties of those material bits, the field. But there's no reality outside of that because there's nothing to create time. And without time, doesn't matter how long infinity is, there's no way to have it. You've already done it. Oops, infinity's over. Yeah. I just went to an infinite number of places and did an infinite number of things. It's over. Done. I'm done. Finished. See? It's interesting. I like it. I like it because it's explanatory, but I also like it. It just, yeah, there's something, and that's it. And there's nothing. But I mean, nothing is really nothing. There's no wait for it, it'll show up thing. No. It's not going to show up. Anyway. Yeah, so I can live with this. That's a video. I just mean, I wish I did a better video, but, you know, it comes out the way they come out. You know, I have to anticipate how people are perceiving things to explain why this change makes so much more sense. Why something called nuclear gravity, okay, instead of Einstein's bent space. No, it's nuclear gravity. The space isn't bent, okay, the field is changed. The nature of the field is changed when you increase the density of the objects in the field. So if you take a bit of space and you put a bunch of extra quantons in it, they inevitably must have more interactions. They have to. You can't, because they can only do one thing. They can only move the speed of light, which is 0, essentially, right? It's the speed of interaction. So the interactions are going to create, you know, it's the number of interactions that are creating the illusion. Wrong word. Oh, good timing. The idea of gravity. So anyway, till next time. It's probably some asshole. Yeah, that's what it is. Hello? Yeah. Yes. Yes, do you have something to say? Hello? Yeah, I hear you. Do you have something to say? Yeah, I don't know who you are, so yeah, I remember Ashley now. Yeah, sure. I still have some of her stuff, or you know, I still have the piano, and I do have some other stuff. But I mean, I'm not going to put up with any bullshit getting rid of it.